Okay, so today we are going to solve absolute value equations and inequalities. The last time we graphed, this time we're solving. Okay, so an absolute value equation is just an equation with an absolute value expression. Okay, and remember, absolute value is the distance a number is from zero on a number line. Alright, when you have absolute value equations, you have possibly what could be extraneous solutions. Okay, and what an extraneous solution is an apparent solution, but when you plug it back in, it's not true. So algebraically, if you solve an equation, you get x equals 7. And you plug that 7 in, but it ends up not being true. That's an extraneous solution. Okay? So with absolute value equations, we're going to be checking everything for extraneous or if it's true. Okay? Now, think back to when we did the parent function table for y equals the absolute value of x. Okay? We had x values that were -2 all the way to +2. And then for the y values, we took the absolute value of -2, and what did that become? 2, because absolute value is always positive, right? But then we also took the absolute value of +2, and that was 2 also. Okay, so when we are solving absolute value equations, we're kind of considering this and working backwards. So you're always going to have a positive and a negative solution. So I'm going to give you an equation, but we're going to actually do 2 equations per problem. We're going to set it up as if it would have been negative inside those bars, or if it would have still been positive. Okay, because absolute value is always positive. So I could throw in any number and still get a positive 50, okay? I could throw in any combination and this be a positive 50, this be a -50, but either way, I still get a 50 as my answer, okay? So working backwards, we're always going to have 2 solutions. We're going to have the positive and we're going to have the negative. We're going to set those 2 up, and then we solve it, okay? Now, what happens if I have something like the absolute value of x plus 3 equals -7? Okay, if I had the absolute value of x plus 3 equals -7, I cannot do this because absolute value is always what? Positive. So how could I have a positive value equal a negative? I cannot. So anytime you have absolute value equals a negative, that's going to be no solution. Okay? So when we solve it, we're going to try to get our absolute value bars by themselves first. That's what we do. We do everything we can, add and subtract, multiply, divide, whatever, to get those by themselves. Then we're going to drop the bars and we're going to split it to its positive and negative solution. And then just solve. Basic equations, okay? Once you solve and get x equals a number, then you plug it in to see if it's extraneous or not, okay? So, if I look at the, we're going to reiterate. No solution happens when an absolute value equation equals a negative number. Okay? So for number 1, absolute value of c equals -1. No solution. I don't even have to do separation there. It's just no solution. I could never take the absolute value of anything and still get a negative. Okay? Now, when I have the absolute value of 2x plus 6 equals 8, are the absolute value bars isolated? Yes, there's nothing in front, there's nothing added or subtracted behind it. So this is where we're going to split our 2x plus 6 equals 8, and our 2x plus 6 equals -8. And then we just solve. So I'm going to subtract my 6, and 2x equals 2. Divide by 2, and x equals 1. Now, Some of y'all are in the habit, which we've always trained y'all, box your answer. But when you get down to this, don't box your answer yet. Okay? Box it after we check for extraneous. So on the right side, 2x plus 6 equals negative 8. I'm going to subtract my 6, and 2x equals negative 14. Divide by 2, and x equals negative 7. Okay? So I'm going to show you how to check it in your calculator so you can, 1, save time, and 2, not do it by hand. Okay? So what we're going to do, we're going to type the value, so 1, and the button right next to 1 is the store. We're going to store 1 for x. So 1, store, and then the button right above that is your variable button x. Enter. Now, anytime I type x, it's stored as a 1. Okay? So we always type our original left side of the equation. So to get the absolute value bars, you're going to hit math, and then you're going to go to the right, and your first option is ABS, that's absolute value. Okay, and then I'm going to type in my 2x plus 6. Enter. That gives me 8, which is what my original equation says, so that is true. That's an answer. Okay. Now I'm going to do the same thing for negative 7. I take negative 7, store for x. Now I'm going to go use the up arrow until that absolute value of 2x plus 6 is highlighted. Press enter and enter. I didn't have to retype it. I could just go back up, press enter, copies and paste basically. But now with my new x value, which is also equal to 8, so both of those are good solutions. Okay? Questions on that? Okay. So now I have the absolute value of 2x plus 12 equals 4x. Do I need to move my x over before I split anything? No, the only thing I care about is that these bars are by themselves. So since they're already isolated, I can split and have it 2x plus 12 equals positive 4x, and 2x plus 12 equals negative 4x. Okay? Now I solve it. I need to get x on one side. I'm going to subtract my 2x. And so that's going to leave me with 12 equals 2x. Divide by 2, x equals 6. Then I'm going to subtract my 2x, and 12 will equal now a negative 6x. Divide by negative 6, and x equals negative 2. And then we're going to check it. So I'm going to take 6 and store it for x. And I'm going to do my absolute value of 2x plus 12. Now that gives me 24. And then I'm going to do the right side because I still have an x that I have to evaluate on the right. So if I took 4x, that's just 4 times 6, which is also 24. That's a true statement, so x equals 6 is a good solution. Okay, then I'm going to do the same thing. Negative 2, store for x. I'm going to go up and grab that absolute value of 2x plus 12. That gives me 8. When I do 4 times negative 2, that gives me a negative 8 on the right. Is that true? No. So that is where my extraneous solution comes from. When it does not match, left does not equal right, then that's extraneous. I mark through it. I do not highlight it. Okay? You marking through it is you telling me you understand it's extraneous. Okay, do we understand what makes it that way? How to find it? We're good. Okay. So for example 4, what do I do first? I need to subtract my 5. So the absolute value of 2x plus 7 is equal to negative 5. No solution. We good with that? Okay. Number 5, what do I do first? I need to subtract 10. I want the absolute value bars by themselves, so I'm going to subtract 10. So 3 times the absolute value of 2x plus 5 equals 27. And then what would I do? Divide by 3. When I divide by 3, do I divide 2x plus 5 by 3? No. Whatever is inside your absolute value bars does not ever change. I do not distribute the 3 to it. I do not change the numbers ever. Okay? All that does is get rid of that, and I'm left with the absolute value of 2x plus 5 equals 9. Okay? When y'all get back from lunch, we're going to finish solving this. Okay. So now that we've got the absolute value bars isolated, we can go ahead and split it and set 2x plus 5 equal to 9, and then 2x plus 5 equal to negative 9. And start solving. So subtract your 5, and 2x is equal to 4. Divide by 2, and x is equal to 2. Do it again. Subtract your 5, and 2x is equal to, very good, divide by 2. And now we check. So 2 stored for x. And then you're going to type the entire left side of your original. So you're going to have your 3, and then the absolute value bars. 2x plus 5, then plus 10. Gives me my 37, so that is a good solution. Store negative 7 for x. Also gives me 37, so they're both good. Do you feel okay with this? Okay. So now on number 6, I've got the absolute value of 8 minus 5x equals 4 plus 15x. Okay, so absolute value bars are isolated. I'm going to separate 8 minus 5x equal to the positive 4 plus 15x. When I go and make the 4 plus 15x negative, okay, you are taking the entire 4 plus 15x, and you're basically just changing the signs because you're going to distribute a negative to both. So that becomes 8 minus 5x equals negative 4 minus 15x. So if you have two terms on the right side, you just change the signs when you make a negative. Alright, so now I want my x's on one side, my constants on the other. I want you to solve it, and I want you to check it. And then we're going to check it. Question. Okay, the left side. You should have x equals this one should be 1/5. Right? The negative one gives you this one?
Yep.
Okay. Okay, are they both solutions?
No.
Mm-mm. The 1/5 should be a solution. That negative 6/5 should be extraneous. Were we able to do that on our own? Okay, do we have questions that I need to go over for that problem before we move on? Okay. All right, number 7, what do I do? I'm going to divide the left side and the right side by 6. So I'm dividing the 6x and the 24 by 6. So I have the absolute value of 2x plus 5 equals x plus 4. And then I'm going to do the same, set up my 2x plus 5 equals x plus 4. And 2x plus 5 equals, what am I going to have on that? Negative x minus 4. Very good. So then I would move my x over. I get x equals, move your 5 over, negative 1. I'm doing this for time. Usually we would work it out. But you would move your x this way, move that way. And then 2x plus 5 equals negative x minus 4. Add your x, you get 3x. Move your 5, and you get negative 9. Divide by 3. X equals negative 3. Okay, so then to check it, negative 1 store for x. 6 times the absolute value of 2x plus 5 gives me 18, and then I check the right side also, 6x plus 24 also gives me 18, so negative 1 is a good solution. Check negative 3 for x, gives me 6 equals six also. So both are a good solution. Okay. Now number 8. What do I do first?
Multiply by 2/3. Oh, yeah, add 6.
Add 6. And then multiply. So 18 plus 6 will give me, and then multiply by 2/3. So you should have 16. 24 times 2/3. And then x minus 6 over 2 equals 16. X minus 6 over 2 equals negative 16. And what do I do? Multiply by 2. So x minus 6 equals 32. Add your 6 and x equals 38. Multiply your 2 over here. X minus 6 equals negative 32. Add your 6 and x equals 26. And then we check. So when you type it in your calculator, you want this fraction, and then you're going to get your absolute value bars, and then do another fraction. And get outside of the bars and do your minus 6. That gives me my 18 that my original problem has, so that's good. Take negative 26, store it for x. Also gives me 18, so both answers are good solutions. We good with that? Any questions? Okay, so that is your 1.4 solving absolute value equations. Now we're going to talk about solving absolute value inequalities. Okay, so this is a little blurry. I copied it from the book. I just couldn't get it clear. Okay, so we're going to look at the statement, the absolute value of x is less than 2. Okay, so remember the absolute value of x is a distance from 0 on the number line. So this is saying the distance between x and 0 has to be less than 2. Okay, well then you should typically think, alright, so I should have a 0, 1, and a 2. Okay, that's the distance that's less than 2. But then also, if I go negative, I can't go any less than negative 2, right? Because this right here, between negative 2 and 2, are the only values that the distance between x and 0 would be less than 2. Okay, so if I have this right here, it's hard to tell, but you got open circles there. What does that look like? An and compound inequality, right? You got 2 endpoints. Okay? Now, what if I said that the absolute value of x is greater than 2? So that would mean that the distance between x and 0 had to be greater than 2. So it has to be more than 2. But it could also be the negative end also. So this would be all of these values less than negative 2. Because the farther you get away from 0, all of those will work. So when I'm going in opposite directions, what is that? An or. So your absolute value inequalities, you're going to be creating compound inequalities, knowing which sign my inequality is. Okay? So, if you have the absolute value of anything is less than a number, that's positive, you're going to have what's inside your bars less than that number and greater than the negative of it. Okay? But we don't write our ands like this, do we? We don't ever write the word and between them. So when you have, let's say the problem is x plus 3 and your absolute value bars less than 5. Okay? It's less than. So the distance between what's inside my absolute value bars and 0 has to be less than 5. So that means I've got to go from 5 to -5, right? So I'm going to take that x plus 3, and it's going to be the middle of my and inequality, right? Now, this less than 5 is always going to be the right side of it. But remember when I taught you and, I said your absolute value, not your absolute value, your inequality symbols are always pointing to the left, less than, okay? So then what I do is I take this 5 and I tack on the -5 on the left. There is my x plus 3 is greater than the negative and less than the positive. So there's my -5 and 5. Okay? So what I did was I dropped what's inside the absolute value bars, copy this whole thing down, and then I just tack on the same inequality with the negative. Okay? You should know what an and looks like. So you should not have trouble with this. The negative always goes on the left. Okay? Now with an or, if you have the absolute value of something is greater than a positive number, then you're going to have that inside the bars is less than the negative, or is greater than the positive. Okay, so if I have now the absolute value of x plus 3 is greater than 5, so that means I want opposite ends. I want the distance to be large. Okay, so I'm going to have x plus 3 needs to be less than the negative, or x plus 3 is greater than 5. The negative always goes on the left, and when you do the negative, you flip the sign. With an or, you know they should go opposite directions, so you shouldn't have to guess that. Okay? Now, that's the y. The distance on the number line is the y. I'm going to tell you something that's going to help you memorize it. Okay? Think about your alphabet. Visualize it in front of you. You go A, B, C, blah, 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 all the way to O. Okay? A for and, O for or. Right? Visualize the alphabet. If I have a less than, what is it pointing to? A or O? A. When it's pointing to the left, it's an and. Think it's pointing to A and. If it's greater than, it's pointing to the O for or. Okay? I told them that last class, and they were getting it like this. Okay? So most people understand it should be and or. It's just setting it up with my negative. How am I doing that? But if you still remember the template that I taught you in 1.1, then you shouldn't have trouble building this for the negatives. Okay? That's where people get messed up. Now, our instructions say we're going to graph the solution, write it in set builder and interval. Okay, I ran out of time with my shortened classes. We got interrupted a million times. Y'all have all been interrupted in your classes from the announcements. I am taking the graph and set builder and all of that off. We're just solving. Okay, I just made it like 10 times easier on you. Okay? All we're doing is solving the inequality. Same thing.
Math teachers, if you have any freshmen that need to pick up their device, please send them to the library at this time. Thank you.
Example A. Okay, so on your worksheet, you're not going to have to graph, do set builder. I just want you to solve. When it comes to your quiz, I'm going to tell you the same thing. Scratch it off. You're just going to solve. On the test, you're just going to solve. Okay? So, if I have the absolute value of 6 minus 3x, minus 3 is less than 6. I do not determine if it's an and or an or until the absolute value is by itself. Okay? So I'm going to add my 3 first. So I have the absolute value of 6 minus 3x is less than 9. Now, it's by itself. Is it going to be an and or an or? An and. So, 6 minus 3x goes in the middle. I have less than 9. Copy that inequality. Tack on my -9. It's not hard to set up. Okay, now I solve it. I need to get rid of my 6, so I'm going to subtract my 6. So negative 15 is less than negative 3x, less than 3. And then what do? Divide by negative 3. And when I do that, what else? Flip my signs. Greater than negative 1. And then this becomes a positive 5. Do I box it? Am I done? What's wrong with that? I gotta flip it. I gotta scoop it and flip it. So I've got a negative 1 is less than x, less than 5. So when you go and check my answer key, you're going to only look at what's inside set builder notation. Okay? Alright, absolute value of 6x minus 7 minus 8 is greater than or equal to 3. What do? So absolute value of 6x minus 7 is greater than or equal to 11. Then what? It's in or. So I'm going to take the 6x minus 7. Now when I do the negative, because negative goes on the left, negative I flip. So less than or equal to negative 11. Or 6x minus 7 is greater than or equal to positive 11. Remember that when you write your inequalities, x always comes first. Some people got that mixed up on their quizzes. Okay. Solve this. I add my 7 and 6x is less than or equal to negative 4. Divide by 6 and x is less than or equal to negative 2/3. So add my 7 and 6x is greater than or equal to 18. Divide by 6 and x is greater than or equal to 3. Is that good? Is that where are my symbols in the right direction? Yes, my smaller number's on the left, so I am good. Okay, number 3. Divide by negative 1. When I divide by negative 1, what do? Flip the symbol. Absolute value of 2x plus 1 is less than or equal to 9. And. So then, what do I write? Less than or equal to 9. Okay, now solve it. Do we have an answer? Less than or equal to what? 4. Did we all get that? Okay. Number 4, what do I do? Subtract 12. So the absolute value of 6x plus 8 over 4 is greater than or equal to 8. This is an OR. So I have 6x plus 8 over 4 is less than or equal to the negative 8, or 6x plus 8 over 4 is greater than or equal to 8. Multiply by 4, 6x plus 8 is less than or equal to Subtract your 8, and 6x is less than or equal to negative 40.
Teachers, would you please send all remaining freshmen to the library that haven't picked up their devices? All remaining freshmen. Thank you.
All right, negative 40 over 6 simplifies to negative 20 over 3. All right, do the same thing. Multiply by 4, so 6x plus 8 is greater than or equal to 32. Subtract your 8. Divide by 6. Okay. What about number 5? The absolute value of 8x minus 11 is less than 0. I see you. I can't hear you. No solution. Why? Yeah, you have a positive. Absolute value is always positive. So can a positive be less than 0? No. So it's no solution. You're going to have to use your knowledge of your positive and negatives with absolute values. Okay? So now number 6, I've got negative 4 times x minus 6 is greater than or equal to 12. What do I do? Divide by negative 4. Absolute value of x minus 6 is now less than or equal to negative 3. What is that going to be? Is it? I have a positive less than or equal to a negative. Can that happen? No. So that's another no solution. So remember how when we were solving equations, I said anytime you have a negative, light bulbs or something should be going off in your head. Hey, something's not right. Okay, sound the alarm. So I sure hope I don't say that and we have a fire alarm. I would jinx this. Okay, so if you see a negative, think back to what absolute value is. Okay? Absolute value is always positive. All right, so look at number 7. Do that. Okay, raise your hand if you're trying to do math. Raise your hand if you're trying to do no solution. No. Okay, we have a positive value. Yes? Can a positive value be greater than a negative? Yes. So this would be all real numbers. Because that would always be true. A positive is always, always, always going to be greater than a negative. So here we are again with a negative. Alarms going off in your head. Something is not right. It's a special case. You have to think about the relationship. Is that going to be true or is that going to be false? If it's true, positive always greater than a negative, that's all real numbers. False would be no solution. Okay? You understand that? Okay, you have a quiz over this next class on review day. So if you have questions, please come see me. During class, email me, before, after school, whatever it needs to be. Okay? So next class, review, quiz, well, we'll quiz review. And then test will be Thursday. Okay?